right, 15 minutes, just like I told you, right? Yeah. So I said this in the last class, but just so everybody hears it, now I've got the extra programs are out there. So if you go in the in class for today, there's the ones for chapters 31 through 37. They're in there. The programs, so 13 through 37 are in there. 1 to 12 are just C programs, and 38 to 42 are C programs. So I did not do those. It's not that I didn't put them in there. I literally didn't key those in, all right, because they were just the C stuff, all right. So we left off last time on chapter 20, or at least that's where I'm going to pick it up, all right. We've talked already about inheritance, and again, every single thing that you have in here must inherit from a class. Every class you create. If you're not sure, you make it inherit from NS object. So they give you an example here, and you should be able to understand that because we've looked at inheritance hierarchies before. There shouldn't be anything that's right there that's surprising to you. All right. And again, you know that now that means an employee can do anything a person can do anything an NS object can do, ergo, an employee can do anything an NS object can do. But it doesn't go both ways. In other words, that it's not necessarily that any person can do what an employee can do. And it goes just the same way it does when you just think about it in, quote, real life, unquote. All right. So what he does is he comes in here and he's using that same program that he's been working with. And you still got the person with their height and their weight, but now, and we've started talking about this before, what the employee has. All right. And as we talked about a little bit last time, you'll notice that the ID and the alarm code are simple variables, and the date is an object. All right. And he also has a method in here to figure out years of employment. And again, it should make sense to everybody that years of employment should only can't think of the word, but it'll come to me. It should only pertain, for lack of better words, to an employee, not to a person. All right. So my hope is, and I haven't tried to make this first 3 weeks not have anything in them. I mean, we've gone through most of this book now. All right. And I will spend a little bit of time on the other book. Literally, when I had to make book decisions, I was like, okay, I want a book that's going to explain Objective-C. That's the first thing I wanted. And the book that you have was not even out when I had to order books, but I had the first edition of it. So I talked to the publisher, and they told me what was going to be changed, and there was some stuff I was hoping was going to be added that was added. All right. There are other books that are out there that I've gotten since then that might be better than this one. All right, I will tell you that Eric, my compatriot over at MATC, this is the one he uses for his beginning iOS class. All right, this is the only book. He goes through that. But those people don't have the background in C that you have. All right. But again, ideally now, when you start to look through this, everything that's in here, that's in blue now, everything, that should make sense to every one of you in here. We've talked about all of it. I don't want to talk about it anymore, but that stuff that's in there should make sense to you. The only thing that's a little bit new, so to speak, in this one, this would be the header file. All right, this would be the header file for an employee. And notice we're importing the person header file. And remember that the person header file was importing the foundations. You know, so as you work your way up type of thing. And remember, since it's an import and not an include, it'll check and see if it's already been included. And also, every other time we've looked at a class, it always has been extending NS object. Well, this is the first time we're extending an actual other class that we've created. Okay? We talked about properties. We've talked about non-atomic versus atomic. If you weren't here, again, it defaults to atomic, so you have to put the non-atomic in. But if you put atomic in, the program it should run a little slower because that deals with threading. So there's more stuff that has to happen behind the scenes. All right. So ideally, if you don't need to thread, you set it to non-atomic. All right. Again, I'm just trying to talk about stuff that I think is, quote, new, unquote, here. So here's how they come in, all right, for the years of employment. And literally that's how they figure it out. And not only that, since they're dividing it rather by seconds per year, all right, I believe that it's returning a double. So for instance, with me, I started in January. So literally, I would be here it's now whatever it is, 21 years and 1 month. So it might be like 21.125 years. All right, you can be as technical with that as you want to or not as technical. I mean, you could round, we could do anything. It doesn't really matter. As we mentioned already, all right, we need to put it says to try out the employee class, open up main and make 2 changes. Import the employee.h file and create an instance. But again, we don't need this one in here now. We don't need that one in there anymore. It's not that it's wrong to put it in, but it's redundant to put it in because we already have that one in another file. All right. Again, it's starting to get, I think at least, fairly complex here. You should understand how this works. Again, this is saying allocate a new BNR object. All right, and after you've done the allocation, do the initialization, and it's going to be referred to as Mikey from then on. All right? And I mentioned to you before, it's not exactly the same thing, but I said it's very similar with what's right there. Is very similar, at least in nature, to just saying int Mikey equals 23. And what I mean is this part right here is basically equivalent to that part right there. And this part right here is basically equivalent to that right there. This can be done as 2 steps also. You virtually never see it done as 2 steps. All right, the log stuff, nothing big in there. Again, I just want to hit on if there's anything new. You'll notice in here, notice what they have. They're using date with natural string. Okay. So they're literally setting a date for the higher date. Now, if you were writing a more complex program, you might be grabbing something like that out of a database. And there are methods in here that will do that. They're not going to put something like that in the beginning book, you know, when we're just starting to get into this stuff. Okay? Yes. Could you chain it? You're talking about could you chain it? Yes. Yes. Yes, you could end up calling them from out of there. Yes. In fact, there are things that are out there that actually will tell you that they would recommend that you do that. All right. I could, if I put the syntax out there right now, I'd be guessing. All right. I'm not really positive what it is, but yes, you can do that. I mean, I've looked at some really ugly things that people have put in there because they're trying to do it in as few lines of code as possible. All right. And notice, as we talked about before, what they're using in here. They're using the more C-like syntax, all right, which is totally legit to do. We've talked a little bit about in here about overriding, all right, and basically, what is this doing? Well, this is saying that if you're an employee, your body mass index is automatically, it's automatically 19. If there was something that was being done in the parent, in their body mass index, if something different was being done and you wanted to do that, you'd have to do that first. You'd have to make a call to super. All right, very similar to the way we did it in Java. All right, the idea is the same. But I think that the example here is kind of convoluted because not everybody's going to have that BMI. But I think they're just trying to show you that to do an override, it's very Java-like, in that it has to have the same header. And then inside of the curlies, you do whatever you want to do. Just the same way that we do it in Java. So there's really no change there. Speaking of super, all right, says, so if you wanted to do that first, and so now what they're doing is they're saying, no, not everybody has 19, but figure out everybody's body mass index. But if you work, it's only 90% of that amount. All right? Again, sort of, a convoluted example because you're making a blanket statement about everybody, which doesn't really make a heck of a lot of sense. In fact, I would argue and say that since you're doing with employees, you should return normal BMI times 1.25. But that's just me. All right? Because most people who work full-time end up with guts like mine. All right, so inheritance diagram of classes that you might know. The key thing to realize here, This is the new stuff as far as what we've created. But as we talked about before, NS mutable array is a type array. There's a mutable date that's type of NS date. There's an NS mutable string that's type of NS string. All right? And what you'll typically find, since it is mutable, all right, since it goes like this, that all of the methods that work with an array will work for a mutable array. But there's certain things that only make sense for a mutable array. Basically, being able to add elements, being able to remove elements. And when you add elements, being able to add them either at the beginning or at the end or any place you want, and the same thing with removal. All right, so those are the biggest differences regardless. And there are other classes here, as you'd probably guess. We'll talk when we get into this about a set and about a dictionary. All right, and believe it or not, you kind of know what dictionaries are anyway. They're key value pairs. We've used key value pairs in PHP. All right, those are what dictionaries are. Sets are like dictionaries, but dictionaries typically have a semblance of order to them. Sets don't have a semblance of order. Sets very good is if you just want to know, hey, is Tony in this list? So you might have a list of thousands of people and you want to know if somebody's in there. That's typically when you use a set. Okay? So we'll get into all that stuff as we get going. One thing that we talked about, I don't know if it's in here yet, there you go. It says when you have a BNR person instance, the object is a BNR person. All right, and literally every object has an is a property to it that tells the type of object that it is. All right, and technically it's an is a or it's an is an, but you get the idea. I don't think there was much more in this. Oh, yeah. Incalls to NSLog, we've been talking about this. It says you've been using the token, %, @ to get to the object to describe itself. That it sends a description message to the object pointed to by the corresponding variable. That returns a string that is a useful description of the instance of the class. All right. What is it? It's going to vary depending on whether or not, exactly what it is you're trying to print out, in other words. So the key thing to remember is if you're working with simple objects, it still is %f, %d, etc. All right. If you're working with things that are objects, not simple data, I should have said simple data types. If you're working with simple data types like an int or a float, etc., same way we did it in C. If you're working with an object, it's % followed by the @ sign. All right. I don't know why they did this. I thought this was a little confusing. Just so you know, there's nothing special here about the angle brackets. They just put it in angle brackets to have it stand out. So I thought to myself, I wonder if anybody's going to look at that and think, wow, angle brackets, what do you use those for? They did it for effect. There's nothing special about using the angle brackets right there, just so you know that. All right, again, if you want to go back and take a look at this, I have written this. And what's kind of cool about it, when you get the chance, and you'll have time in here, but take a look at this and look at how I did it. And if you do it yourselves, if you have the time, see what you did that was different than me. I didn't spend a lot of time on these things. I literally did went through about virtually the whole book between Christmas and New Year's. All right. And if I would be a drinker, that would have been a good reason for me to have drank on New Year's Eve. But okay. Object, instance, variable, and properties, chapter 21. This may be one of the hardest chapters in the book. All right, it doesn't necessarily have to be, but I think it is. It says, usually, object instance variables fall in one of these three categories. All right, an object type variable, a pointer to some simple type of object, like a string or a date, etc. All right, a 2-1 relationship. It says a pointer to a complex object. Well, a complex object is that person. Typically it's a user-defined object that's got more to it. It's like a structure. It's got many ingredients inside, for lack of better words. All right, but that would be a 2-1. A too many, and I think we talked about this a little bit earlier. That would be an example like if that person or an employee had children, and you had to take all that stuff and basically encapsulate that into the object. All right, and there's sort of a relationship here in that in some of the stuff that we've talked about in the database terms. a one-to-one versus a one-to-many relationship. The ideas aren't that dissimilar. All right. Again, you see this and you see that it's mutable array, and it's mutable array because what we want to be able to start saying in here are things like, okay, with a person, we may want to add something like, how many kids do they have? Are they married? Type of thing, where something like that can change over time, and that's what they're showing here. So that's what they've added as a spouse and children. And again, the reason, especially with this, you could, that's mutable because that can very well change over time. All right. There you go. Well, and I think what they're showing here too is, notice what we're saying. We're saying spouse is basically can do everything a person can do. A spouse is a person. But you can't say children are a person. You can say children are people. But you don't know how many. If it's one, it's a person. But if it's more, it's people. Since we're not sure how many, and since that can change. But you're right. Right now we're assuming that you only have a single spouse. And you're also going to have cases, you all know this, you're going to have cases where the person won't have a spouse, but they'll have children. All right, so there's all sorts of complexities that you can that can happen that you can build into it. All right. As it says here, there's two important side effects when you talk about objects pointing to rather than containing other objects. And last semester, I always got the feeling, at least with some of you, I think, what's the old saying? You took the pointers like a duck to water. I think other people did everything they could to not use them. All right, it's like, my God, these are just terrible, and they're not terrible. They give you the power to do things that is impossible to do in other languages. And now's the time to tell you, because we're not in the Android class. But guess what? Java uses pointers all over the friggin' place. It does. You just can't manipulate them yourselves directly. But you've been using them ever since beginning Java. All right? Because a lot of the stuff that you do when it goes down to machine level is done through pointers. It is. All right? And you saw that R file today. If you notice that R file, what was in there? Anybody know? They look damn a lot like addresses to me. All right? So you're dealing with them now. So as it says, the side effects, one object can take on several roles. Well, yeah. You can be an employee. You can be a husband, or an employee and a wife. You know, an employee and a husband and a father. An employee, a wife, and a mother. All right? Plus, it's even more complex than that, because occasionally, at least, two people work at the same place. All right? Second, that's what they were getting to here in that thing with ARC. Remember that every time you go and you create something, you're responsible for it if you create it. So if you don't, what happens? You may or may not have noticed this, and my hope is that by now at least everybody's at least gotten into Xcode. But back in about Xcode, I think it stopped in 4.5. There was, when you first got up and you started to create your project, there was a checkbox in there that said, do you want to use ARC or not? In other words, if you didn't do that, if you didn't check it, you were responsible for these retain and release messages. All right, you had to do it. Now, they just decided that's the default. So you basically have got to go in and code and turn it off if you don't want to do that. All right, there's a few other things that they've done that with too. So they talk about this, and we have talked about it before. All right, it's just the idea of who is taking ownership. If you work in a situation where, let's say that you're not using, let's say that you work in a situation where you're not using ARC, all right, and somebody is coming in there, so somebody is going to be responsible then for setting things up and making sure that things are allocated and things are deallocated. And that's a job. All right. There we go. Okay. Then they come in here and they start adding stuff to it. Okay, it says, let's create a new file. In fact, let's only back up a little. Okay, it says, let's expand this time project to see how it works in practice. It's not uncommon for a company to keep track of what assets have been issued to which employee. The only thing I could talk about with this is, it just so happened yesterday I came home and the TV was on, and ABC News with Diane Sawyer was on. And they had a couple on there. I found this interesting. That what they do is they go to all sorts of places like airports and other places where they know they've got lost and founds, and eventually, like once a year, they go and sell everything. All right, and that's how they make a living. They go to all these things because most of the time they have to post them. They buy things and then they sell them online. All right. Why am I telling you? Because that's their assets. You could look at it that in an asset, now that's my machine here, but the other one, the older one that I have, is the school's machine. All right, and this is the school's machine. So technically, at some schools, when you go to a school, literally it's built into your tuition. They give you a laptop to use for a couple years. Most people equate things like that with assets. Other people will say, well, we look at assets another way, but it's the whole thing that you talk about tangible and intangible assets. Okay? Are they measurable or are they not measurable? So they're coming in here and they're adding something new. All right? And what they're saying in here is what we're going to have. I should just jump back to it again. It says, you are going to create an asset class, and each employee will have an array containing his or her assets. So you would guess that when an employee is first hired, they probably have no assets. They haven't been given anything yet. And some employees would have totally different assets than other employees. We are given laptops here to use by the school if you're an instructional staff. If you're in instruction. If you are a staff member, I don't know, like Tammy, the secretary and stuff, I don't know if she gets a machine. Not to be funny, but I don't care. She probably doesn't care whether I have one or not. So what I'm saying is different kinds of employees would conceivably have different types of assets. All right? So it says, remember that when an object has no owners, it's deallocated. There is an NS object method that's called DALock. Notice if a class rewrites this, then this method will be executed when an instance of the class is deallocated. So in other words, if there's something special you wanted to have happen, you could put the code in there. All right? And I've given you this example before. In many ways, it's not that dissimilar to, you've got constructors in Java. You actually have destructors in Java, but no one ever calls them. No one ever calls a destructor in Java because you can call it, but you have no control over when it's actually going to be executed. It could be called but not executed at that time. So typically, when you want to have something happen in Java, we never really did any work with this. But what you do in Java is Java has what's called a finalize method. And what that says is, hey, whenever you call the destructor, whenever that happens, do this stuff. And what you do is you do things like close database connections and close files and whatever it is, housekeeping type of stuff normally. And that's normally, if you were going to override what was in the DALock, that's typically what you do in there. Now, could there be other things? It depends on the situation. Of course, there could be. All right. It says to make it clear, come on, which particular instance of an asset is being deallocated, you will also override the description to return a string that includes it. In other words, you're trying to make sure as you're doing this that what you're about to deallocate is what you mean to deallocate. It's the equivalent of if you were writing a database program and somebody could remove a record, before you removed it, you'd come back and say, you are about to remove Stephen Helsel from this database. Are you sure that's what you want to do? And you could either do it or back out, type of an idea. All right. So what they do, as mentioned here, is they add this too-many relationship to the employee class. All right. That's going to be that MS mutable array. And they say there's two important things to realize when you're working with this stuff. First, when an object is added to a collection, the collection establishes a pointer to the object, and the object gains an owner. For the stuff that we're working on in here, you're the owner. The only way that it could be somebody else being the owner would be if you were working with someone else. All right. Also, when the object is removed, the collection gets rid of the pointer to the object. That's what Arc does for you. It automatically does a retain message when you create the object. All right. And when it feels that you're done with the object, it does a release. You do have some control over when that happens, though. All right. And if you never, it is possible in some programs, you create an object and it lives forever. If I'm working for a bank and I create a bank account object, it's not inconceivable. I could, at birth, somebody could start a bank account for me. And if I live 90 years, that object could literally be alive for 90 years. All right, it says there, to set up this relationship, you will need to create a new instance variable to hold a pointer to the multiple array of assets. So in other words, That's it here. And really, again, just remember that if you remember it no other way, that in the Java class we talked about an array list. Remember, we talked about arrays for a long time, then we talked about an array list. That's basically what this is. That's their name for an array list. All right. And it says here, look at this line right here, the add asset. Okay, right there. Okay. And it says, notice that the line that says the class asset, as the compiler is reading this file, it will come across the class named asset. It does not know about this class, so it will throw an error. Well, what the heck does that mean? All right. It means that if you don't provide the information that the compiler needs, the compiler will not go on. All right. I shouldn't say that. It'll go on, but it'll throw an error, and it will not compile correctly. Right. It's not an interpreter. It's a compiler. Okay. So it says, this line right here basically tells the compiler there is a class called BNR asset. Don't worry, we'll let you know about it when you have to know about it. All right. So when we come in here, it says, let's go back and look at that. That line right there, okay, says, hey, right now there will be a method in here that doesn't return anything that's called add asset, and it's going to have a parameter that's going to be a pointer to BNR asset. So the reason that I'm mentioning that is that line right there, that line that you see in blue, that means you have to put in this line. All that says is someplace else in the program, we've defined a class that's named BNR asset. Does that make sense to you? It's not opening up a header or anything else. It's just saying somewhere else in the program, in this program, there's going to be a class that's called BNR asset. I would tell you it's kind of like an extern statement, but it really isn't. But it's not an include either. I don't know exactly. I don't know if there is an equivalent of it in something we've talked about in another language. Probably is, and it just doesn't. It just escapes me right now. But the point is, sometimes when you use this, if you want to refer to a class like BNR asset, and you don't have it defined in here, or it might not be. Before you use it, you just have to put in a class designator. Now, did I explain that well? Probably not. It is explained very well in here, or better than I did, on page 156. All right. Again, when you look at this, this is by far, I think, the most complex thing that we've looked at thus far. All right. You may or may not agree, but I sure think it is. So look at some of the stuff that's in here. A thing to realize is when you're doing this, notice right here, we're returning the employee's assets. That should make sense to all of you. Okay? Literally what that's doing, literally that word copy, that's what it means. Return a copy of what's in the array. Not the array itself, but return a copy. And when you start working with this stuff, you work with copies all the time. Because by and large, when you start working with this stuff, everything is not trusted. So if for some reason something gets screwed up, you still have the original. Okay. Now, we talked about this. Is assets nil? All right. That's the same thing right there as saying if underscore assets equal nil. And when should there be nothing in it? Like we talked about, when you just hire somebody. Okay. That's really the only time that should happen. It's possible that they could have an array with nothing in it, but you might set it up so it's got something in it, a dummy value, whatever. And what are we doing? Well, we're adding that asset to our that object rather to our assets array. And again, that's where, like I said, that's the equivalent of like an add method in an array list in JavaScript. All right. And now what are we doing in here? Well, we're figuring out what the cost is, all right, what the cost is right there of all the assets that we've given to that employee. So we're telling them to filter its way through that list, okay, and add up every value that's in there. Now, I mentioned the other day that this literally is one of those iterative type of for loops. We're not changing the value of anything in the array there. We're just changing the value of a local variable that's called sum. So we're going to figure out what the sum is, and when we get done, we're going to return it back. All right. I'm not sure, so what I'm about to say, Bob or somebody else may disagree with this, but I think it probably would be possible that you could literally have a negative amount. You actually could when you think about it. All right. And I'm sorry, you probably couldn't have a negative amount. Sorry. All right. You could say that, you gave somebody an asset that really wasn't worth anything, but then it's worth nothing. So I think but what I'm saying is, I think what they're saying is that even if you have no assets, then you have nothing. You don't have a negative amount, which is, I think they use the unsigned. That's why I'm saying is the reason I think they did it that way. Oh yeah, it's just like what you said. It's like what you said before too. It's like with the thing with Utah. Yeah, you can come up with exceptions to everything. Yes. Yeah. Oh yeah, we have our own type of amortization process as opposed to the way a business does it. You're right. Yeah. All right, then they come through here, and what are they doing? Well, they're saying that it's not just the employee's ID we have to worry about, it's also their assets. All right, so they're adding to it. I'm not sure why they did it like this, because it's the same line, except all they did here basically was they added this to it. Okay. And Bob, you'd asked about that before. Oh, Craig, I shouldn't have clicked. I might be going back to, okay, yeah. But when you look right here, notice what they're doing basically. Okay, they're calling two different. They're calling self. No, they're not. Forget it. It's just way too late in the day. Yeah, it's way too late in the day. But when you look here, now he's trying to put everything together. So here you've got employee stuff. All right. Here you've got employee stuff. Here you've got person stuff. And here you've got employee stuff. And after you've kind of put all that stuff in there, you want to add them to the employee array. Okay? Then after you've done that, now you've got an employee there. Now you come in and you start adding assets for that particular employee. And the way he does this, he just comes up with kind of arbitrary types of stuff there. So the first time through, it'll be $350 plus 0 times 17, so $350. Then free $350, etc. In other words, he's trying to make sure that when you come through here, you've got different values as you work your way through. And he tweaks with this stuff. I got this to work. I made a couple changes to it, and it didn't work. It was one of those things where, geez, I didn't change anything. Then I did. And this will work. You should get the same results if you run this as what's shown here. All right, notice, here's the key thing. It says tidy, right? As the objects become unnecessary, they are being deallocated. So again, as you sit there and you basically remove the object using the remove object method of NSMutableArray, that pointer to that object is also going to be deallocated, is what they're saying. This language, more than C, more than C++, more than C#, all right, is really, really memory leak conscious. All right, and I don't mean that the other ones are not, but this one is more, I think, than the other ones are. All right, so they have another challenge at the end, which again you have on yours. All right, class extensions, chapter 22. Says so far you've declared all your properties, instance variables, etc. in the class header file. Okay. However, not every property should be advertised in a class's header. What you basically end up doing, remember what a .h file is. All right, it's a header file. I know you know that, but the point is, when you're working with interfaces and implementations, okay. The implementation is the code behind it that you don't want anybody to see. The interface is your picture to the world. And I've given you this example before. It's like when I come in here and do this. It's pretty obvious what the interface is, right? It's pretty obvious. However, when I do this, all right, and I click that, I don't know exactly how that happened. That's the implementation. And what the author is saying in this chapter is sometimes you want to make sure that when you are setting up a class, that some of the properties are not known. You don't want to show them. They're super private, or whatever you want to call them. You don't want to let anybody see them. So rather than creating them in the .h file, you put them right in the .m file. You hear what I said? That's what this whole chapter is. All right. So he says as an example, and it's a pretty good one. The alarm should be private because that should be known only to the person, you know, whose alarm code it is, and to the company, or maybe the alarm company, or whatever. But it shouldn't be something that's shared. All right. So they're saying that right now it's in there. But we can remove it from there. And again, we can remove it from the .h file and put it right into our .m file. Okay? And there's nothing at all wrong with doing that. You don't want to do that with everything, because if you do that with everything, now you have no interface. So every time you do that, you're taking away from your interface. You're taking away from what you're showing people. All right? By making it more private. Again, sometimes there's a very good reason for doing that. All right, hiding mutability. It says, let's look at a slightly different case for putting the declaration in the class extension rather than the header. It says, in the employee, you declared an assets array that is an NS array, an add asset method, and an assets instance variable. A developer will see both the property and the instance variable advertised in the header, and may be uncertain as to which you intended outsiders to see. It says, now that you know about class extensions, the solution is simple. Move the assets instance variable itself to the class extension. So as they mentioned there, if you do this, it's an interface that you put inside of the .m file. But it's an interface that must come before basically anything else other than the import statement. Okay. And like I said, that's the chapter. So they, as you can see, they've removed what's here and they put it up here. And it really, it's funny the way that that they did it, except, I mean, what's different? It's still an interface, but you don't say that it inherits from anything. You just say interface. Okay? Other than that, it's the same line that you saw previously. So if we just took this part out, you could copy everything in. A subclass has no access to its superclasses' class extensions. That's the privateness out of it. They can't see it. All right? And again, we've already worked with private variables. You know what private variables basically are. And they tell you here, if you try it, it's not going to work. All right. Let's just quickly go into memory leaks. Maybe we'll even call it a period then, but kind of an important chapter, kind of a weird chapter if you haven't dealt with this kind of stuff before. But it says it's pretty obvious to have relationships that go in two directions. For an example, maybe an asset should know which employee is holding it. So they're adding relationships. It's almost similar to a many-to-many type of relationship. Not exactly, but that we've talked about before. All right? So as it says, from a design standpoint, you would say that you're adding a pointer from the child to the parent. There already is one from the parent to the child, but now you might want one to go in the other direction. Okay? So they add another pointer instance in here. And before you say, well, geez, can you do that? When you're in charge, you can do basically just about whatever you want to do. All right. Sometimes you might have to shoehorn it in or do different things to make it work, but you can almost always make it work. All right. And what they get to on the bottom of page 167, it says, okay, when you're doing all this stuff, how do you do it? So they get to that here. It says, this brings us to a style question. When people use an asset class and an employee class together, how do you maintain your consistency between the two of them? All right, it says that is, an asset should appear in the employee's assets array if and only if the employee is the assets holder. All right, so only if they're your assets should they show there. Okay. And it says there's 3 ways you can do it. You can set the relationships explicitly. So the vice president has a town car. Okay? Who holds the town car? All right, you're setting the holder to vice president. In the method that sets the pointer, you can add the child to the parent's collection. Or, and it says you typically won't do it this way. Or in the method that adds the child to the parent's collection, that's when you set it. And that's what they choose to use in this one. So this is what they add. Again, that's that self variable that we talked about before, which is similar to the this pointer that we had in Java, but more powerful. Literally, it is a pointer to the current object. And if you've never done this, if you start writing programs and you are in a method, type in self dot, and you can see all the different stuff that you're typically able to do. It says here, notice that now none of the employees with assets are getting deallocated properly. It says also none of the assets are being deallocated either. So what the heck's going on? Well, again, this is it. What a great thing to talk about at the end of a class, because it's one of the more complex things in the book. It's on the bottom of 167. As it says there, the asset owns the employee, and the employee owns the assets array. And the assets array owns the asset. It says it is an island of garbage created by a circle of ownership. It's true. I mean, that's actually very well put, because that's what it is. It says these objects should be getting deallocated to free up memory, but they're not. So what you have is what's known as a strong reference cycle. And as mentioned, that's the source of a lot of memory leaks. All right? And in some ways, this isn't the greatest of examples, but non-computer, it's kind of like the old case of where you heard the saying, the left hand doesn't know what the right hand is doing. All right, where I think Stefan's doing something, he thinks I'm doing it, so it's not getting done, type of a principle. All right. So it says to find strong reference cycles in the program, you can go in and there's something that you can use inside of Xcode that's called instruments. And it's fairly complex, and they've actually changed this a lot in version 5. This is one of the places where Xcode has changed. But when you go in there, you can run the profiler, and you can tell it to look and find memory leaks for you. What it does is it goes through, it's kind of like running a debugger, but rather than debugging and finding errors, it's looking through and it's trying to find places where it thinks you could potentially have memory leaks. And it's not going to fix them for you, but it's going to alert you to, hey, there could be problems here, and this is what you might want to know. All right. So it says, however, the program runs typically and exits quickly. So you'll typically want to put a sleep thing in there at the end of your main, so you don't lose the information. All right. That was not at all any kind of high-tech, explanation. But what I will tell you is that when you start looking at that stuff, just go online, because I just read a bunch of documentation out there on it. I just looked it up and started reading. So as it says, as your program runs, you can now browse the state of things. Okay? It says you have two instruments to choose from on the left-hand side. Clicking on allocations will show you a bar graph, and that literally will. So it'll show you a graph up here over how memory is being used, allocated and deallocated, etc. All right, it says to look for strong reference cycles, click leaks there on the memory bar. All right, and choose cycles and routes, and you get a drop down. And it'll start showing you where it thinks there are potential problems. All right, that's about as heavy as I want to get into this, because typically we're not going to be that concerned with it. I don't think we're doing anything that's that major where this is going to become a really big issue. Could I be wrong? It wouldn't be the first time. But I don't think that's going to happen. All right. So, it says, so how do you fix that? You use a weak reference. It's a pointer that does not imply ownership, so that's how it changes. So that's implying that somebody else owns it. And so by default, if you put nothing in there after property, it defaults to both atomic and strong, meaning that you are providing for threading and that you're the owner. So as always, if you want to be specific and let it know, then you have to put this stuff in. All right? And that's kind of the gist of this chapter right here. So it says in a parent-child relationship, the general rule for preventing this type of thing is the parent owns the child, but the child should not own the parent. You shouldn't have a cyclic type of relationship. Sometimes things like that are set up, either purposely or accidentally. Usually, more often accidentally. There could be a very valid reason for doing something like that. All right? But it's one of those cases where, yeah, there might be a valid reason, but there also is another way of doing it. probably a better way of doing it. So they add another array to the mix. As it says, what if you wanted an array of all assets, even ones that have not been assigned to a particular employee? Okay, so we bought a bunch of laptops, but we haven't given them away yet. It says you could add the assets to an array as they are created. So that's what they do in here. So that's the all assets. Whoops, right there. That's the all assets array. So right now with there, nobody owns those assets, but you can still figure out their value. You know, again, if you say, oh, I don't get it. Yes, you do. Drive by a car lot. Who owns those cars? Well, technically the car owner does, but what you can, it's the same kind of thing. All right, those are assets that are out there. So if we imagine that they weren't owned by anybody, type of an idea, and eventually they would be sold to somebody, it's the same kind of thing. All right, so as they go through there and they add these, they also add them to the all assets array. All right, why? So when you run this, it looks like this. So you've got an idea before, again, notice laptop 3 and laptop 8. I'm sorry, laptop 3 and laptop, well, it says 5. But I'm looking at 3 here, and it's been unassigned. It's still there, and it's still worth something, but maybe that employee left or got a different computer or went to a different department or whatever. Whatever it happens to be, whatever that asset happened to be. It says if you are explicitly declaring a pointer to a pointer variable, you can put weak in front of it. That leaves no doubt. Again, this isn't something we should have to worry about in here. All right. As it says, if you want, you can go into the system itself and you can look in there and you can find more out about the history of it and the way things used to be. Okay. All right. I think that's good for today. Sorry that it worked out the way it did. Like I said, Tony and I were talking on the way back, and I got to watch what I'm saying because I'm taping. But you probably heard me say this years ago when we adopted my daughter in Colombia. We sat there and we got a phone call from our interpreter. She said, well, I'll be at your hotel in 15 minutes. It took her an hour and a half, literally. So we were literally sitting there on the bed waiting because we were going to see our daughter for the first time. She starts laughing. And she sounds kind of like Sofia Vargas. That's how she talked. She's like, no. This is a Colombian 15 minutes. Okay. All right. So I thought we were going to have a 15-minute long meeting. I guess that is a 15-minute long meeting for some people who were at the meeting. All right. So we'll pick it up next time. I want to do some stuff. I want to code some stuff. And we'll eventually finish the stuff that's in this book.